You're working a part-time job and you're in a flat $20 bonus plus $12 an hour. After a week, you take home 68 bucks. How many hours did you work? To solve that, you need to undo multiple steps, and that's exactly what a multi-step equation is. Welcome to Phorge Mathematics. I'm Ryan, and today we're solving equations that take more than one move to crack. So by the end of this video, you'll be able to handle any two-step or multi-step equation confidently. Let's go ahead and dive into it. So by the end of this video, you will be able to identify steps needed to isolate a variable in a multi-step equation, apply inverse operations in the correct order, so reverse PEMDAS, solve equations involving distribution, combining like terms and variables on both sides, and then verify your answer by substituting back into the original equation and then solving. So let's hop into it. So part one, isolate the variable. So the goal is to get the variable alone on one side. There's a multi-step, so one side of the equal sign. So remember, an equation is anything that has an equal sign balancing two different sides. So the rules, whenever you do to one side, you must do to the other side. So in a multi-step, that means you have to do two or more steps. And then the order is you want to do addition / subtraction first, and then multiplication / division, and then exponents and any remaining exponents if you have any, and then parentheses. And you do that in reverse of the PEMDAS order. So step two, or a two-step equation. So think of it like a chain of operations wrapping around the variable. And what we need to do is we just need to unwrap that variable and doing a reverse PEMDAS until we can isolate that variable on one side. So let's look at this equation. 3x plus 7 is equal to 22. So let me write PEMDAS off to the side to keep ourselves straight. So now what we need to do is we need to start from the bottom and work our way up to the top. So addition / subtraction. Do we have any addition? Yep, plus 7. So let's subtract 7 and 3x minus, so then we have 3x equal to 22 minus 7 is equal to 15. So now, do we have any more addition / subtraction? Nope. So now we need to look at multiplication / division. So now we have 3 times x. So what do we need to do to reverse multiplication? Divide by 3. So divide by 3. Make sure we do that to both sides. This cancels out, and now we're left with x is equal to 5. Awesome. So now that we've solved for x, let's go ahead and plug it back in to double check that we got it correct. So x goes, so we have 3 times 5 equal to, 3 times 5 plus 7 is equal to 22. Okay, so now that we're solving the left-hand expression, we're going to start from the top and move our way down in PEMDAS. No parentheses or exponents, so we can go down to multiplication / division. 3 times 5 is equal to 15. And then we have plus 7 equal to 22. 15 plus 7 is equal to 22. And that is our real answer. So good to go. Okay, so let's move on down to part 3. So when equations have parentheses, make sure that you distribute first and then go from addition / subtraction moving up to multiplication and division. Okay, so in this case we have 2 times, and then parentheses x plus 4. So what you want to do is you want to do 2x and then 2. So you have 2, and this simplifies down to 2x plus 4 is equal to 18. Oh, I'm sorry, I already made a mistake. This should be 8. 2 times 4 is 8. Now we subtract 8 from both sides, so you have 2x equal to 10, and then divide by 2 on each side. You have x x equal to 5. Perfect. And we can plug that back in and see if we got it right. So we have 2, 5 plus 4 equal to 18. 5 plus 4 is equal to 9, because remember, in PEMDAS we set parentheses first. So we have 2 times 9 equal to 18. And then 2 times 9 is equal to 18. So now, there we go. Good to go. So another way that you could have solved this is you could have just divided by 2 first. So let's start. Let me rewrite the equation over here. Okay, so right off the bat, you could have just divided by 2. But make sure you do both sides. This cancels. Now you have x plus 4 is equal to 9. Then you subtract by 5, or excuse me, I'm sorry. Subtract by 4 on both sides, and you have x equal to 5. And since we already plugged in 5 down here, we know that's the right answer. These are equal to each other. So that's another way you could deal with that. Okay. So think of it kind of like unboxing. So when you pull it out, you want to see that you have 2x plus 4, or 4. So you have 2 boxes of x plus 4, and make sure that you multiply by 2 so you get the total amount of whatever you have. Okay, let's move on to variables on both sides. So in this equation, as you can see, there's 5x and 2x. There's an x on each side of the equation. So remember, what is the goal when we're trying to solve an equation? We're trying to isolate x on one side, which means that we're going to have to bring one of those x's onto the other side. So what I like to do is I see whichever one has the larger coefficient. So in this case, the left-hand side with 5, the right-hand side has 2. So what I do is I just subtract 2x from both sides. And now I'm left with 3x minus 3 is equal to 9, because that cancels out. Now, I have 3x minus 3 equals 9. This is just like a single or a two-step equation with an x on one side. So I add 3 to both sides because that's the opposite of PEMDAS, starting at the bottom. 3x is equal to 12. Divide by 3, and we have x is equal to 4. Let's plug that back into our original equation and see if we got it right. 5 times 4 minus 3 is equal to 2 times 4 plus 9. Okay, so what we need to do is we need to do PEMDAS starting from the top to the bottom. Just to keep myself straight. Okay, any parentheses? Nope. Any exponents? Nope. So now we can move down to multiplication and division. So remember, we need to start from left to right, and we need to go all the way across. 5 times 4 is equal to 20, minus 3 is equal to 2 times 4, 8, plus 9. 20. So now any more multiplication or division? Nope. Now we move to addition and subtraction. 20 minus 3 is 17, equal 8 plus 9 is also 17. Boom. Got it good? So we know that x plus 4, or x is equal to 4, is the final answer. All right. Let's go through some worked examples. So what I'm going to do is I'm going to write PEMDAS off to the side here, so I keep myself on the right path. So we have 4x minus 5 is equal to 11. So I'm going to add 5 to both sides because we're working from bottom to top. So we have 4x equal to 16. Divide that by 4. X is equal to 4. Let's plug it back in and see if we get the right answer. 4 times 4 minus 5 equal to 11. Now we're going to be working from top to bottom. No parentheses, no equations or exponents. Multiplication slash division. 4 times 4 is equal to 16 minus 5. Now we can do a subtraction. We get 11 equal to 11. Good to go. All right, so now we have a so we can either distribute first or we can just divide by 3. I like dividing by 3, so I'm going to divide by 3. Do that to both sides. Cancel, cancel. That goes. So now we have 2x minus 1 equal to 7. Now we can add 1 to both sides. And now we have 2x equal to 8. Divide by 2, x equal to 4. Now let's plug that back in, see if we got it right. So 2 times 4 minus 1 equal to 21. All right, so we have 2 times 4 is 8. Eight minus 1 is 7. 3 times 7 equal to 21. And 21 equal to 21. Good to go. All right, let's move on to example 4. Now notice we have a variable on both sides. I'm going to subtract 3x from both sides because I like getting rid of that. And now I have a positive coefficient in front of that variable that is easy to work with. Okay, subtract by 4. And you have 4x equal to 16. Divide by 4. And you got x equal to 4. Let's plug it back in, make sure we got the right answer. 7 times 4 plus 4 equal to 3 times 4 plus 20. Okay, we have multiplication, so 7 times 4 is equal to 28. Plus 4 is equal to 3 times 4 is equal to 12 plus 20. Now we can go through addition all the way through. 28 plus 4 is equal to 32. 12 plus 20 is also equal to 32, so good to go. So let's look at this trap. You could either distribute or divide by 2. I think we should distribute. So 2, distribute out. So you got 2x plus 6 is equal to 2x plus 6. So if we were to simplify this all down, what we're going to get is we're essentially going to get, if I subtract 2x from both sides, 6 equal to 6. So what does that mean when we have a true statement like this? This means that there's an infinite amount of answers. You could plug whatever you want in for x and you're going to get a correct answer. So that's kind of a special solution that you see sometimes, but not always. All right, let's move into some common mistakes. Okay, so undoing multiplication before removing the plus or minus, wrong order. So if you were, let's say you have 2x plus 6 is equal to 4. If you divide by 2, and then you're going to have a leftover plus 4, you're going to get the wrong answer. So make sure that you're always using PEMDAS. And don't be afraid to write PEMDAS on the side. As you can see, I do that all the time. Distributing only the first term. So, for example, 2x plus 4 does not equal 2x plus 4. So when you do that, you need to make sure that you go 2x all the way, or 2 times x, and then 2 times 4, and you get 2x plus 8. Dropping a negative sign when moving terms across the equal sign. Yeah, that happens to me all the time where I forgot to divide by -1 whenever I have like a negative x or something, so just be careful with the signs. Assuming variable cancellation always means no solution. So check, and you need to simplify all the way down until you get a true statement or an untrue statement. If it's an untrue statement, that means that there is no solution to the answer. But if you have like 0 equals 0 or 6 equals 6 like we had on the last problem, that's how you know that it's either infinite amount of solutions or no solution at all. Skipping the check step. Always substitute your answer back in. I can't tell you how many times I've gone to double check my answers and I found where I did simple algebraic mistakes. So always make sure that you go back and double check your work. That's a great test taking tip. All right, practice problems. Go ahead and pause right here. And and see if you can solve these 5. And then I want you to put in the comments how many you got correct. Okay. Look down here and see how many you got correct. Go ahead and smash that like button, subscribe, and I'll catch you in the next one.